Hi, I'm Mike Smith. Welcome to this training on the controller area networks found on BRP vehicles. Most electronic modules on BRP products use the CAN bus to communicate with one another. Depending on the vehicle in question, there can be anywhere from one to many modules communicating on the CAN network. Since CAN is a standard protocol, the principles are the same, regardless of the unit in question. The modules broadcast their signals over the CAN bus through the CAN high and CAN low wires. The high and low signals are mirror images of each other. Some modules, like the ECM and the gauge, send and receive messages. These modules also have a diagnostic function, which is why they are visible in buds. Some modules, like the radio on a Roadster, send and receive messages, but since the radio does not have a diagnostic function, it is not visible in buds. Other modules, like the yaw rate sensor on Roadsters or the thermocouple module on Ski-Doos, can only broadcast messages. The details for each vehicle are in the CAN subsection of the shop manual. The most up-to-date shop manual is in the shop manual directory on the Knowledge Center. If a component or system malfunction is detected, a module can do any of the following. It can generate a fault code. It can trigger an error message in the gauge. It can turn on a fault indicator light for major malfunctions. It can limit or inhibit vehicle or engine operation, or it can do nothing at all. If a module loses communication with the network, the other modules can register a fault when their messages are not received. However, they may not be able to or choose not to notify the operator. You will not be able to read the missing module with buds, which may be the best diagnostic indicator of the problem. If there is a problem with the network in general, such as CAN wires shorted to ground, CAN wires shorted to the battery, or CAN wires shorted together, the modules will not be able to communicate with each other at all, or with buds. If buds can communicate with some but not all of the modules, check for power and ground to the missing module. If the module is not powered up and not operational, it cannot send or receive messages. Also, check the CAN wire resistance between the diagnostic connector and module. At the same time, you may want to check for corrosion in the connectors. It's better not to disconnect the module connectors with the vehicle powered. Turn off the unit to disconnect the module connector. Here's a real-life example on a 2014 Outlander XMR. The owner complained of a scrolling DPS error message and a check engine light. The technician described the symptoms as, "We cannot communicate with the unit using buds. The ATV will start and run, there's no gear position indicated, the DPS is inoperable, but other than that, it runs fine." There might be a communication problem with the vehicle. If you suspect a CAN communication problem, the first test is to connect buds and try to read the vehicle. Make sure the USB telltale light is on. If not, check your buds installation, connections, and drivers. If the CAN telltale light is off on the MPI, the vehicle is not responding on the CAN network. Look for a problem affecting the entire network. If the CAN telltale light is on, some modules are communicating on the CAN network. Look for a problem affecting individual modules. To check the CAN network, turn off the unit and wait for the electrical system to power off. Measure the resistance between the CAN wires at the diagnostic connector. You should read between 50 and 70 ohms. If you're performing this test on a Spider, remove the main relay. BRP is standardizing its CAN networks to have the CAN terminating resistors in the ECM and the gauge. However, some units can have terminating resistances elsewhere. For example, some Ski-Doos have a terminating resistance in the diagnostic connector cap, while Roadsters have it in the VCM. If you do not measure approximately 60 ohms at the diagnostic connector, check the diagnostic connector cap for terminals. The cap must have terminals in positions 1 and 2 for it to have a resistance. But just because it has terminals doesn't mean it has a resistor. Check the BRP buds chart available through the buds directory on the Knowledge Center. If you need to use the resistor with the MPI-3 on the unit, there is a resistor in the cap. To test the resistor, measure the resistance between terminals 1 and 2 of the cap. If reading a low resistance, for example, below 30 ohms, the network will not be able to communicate. In this video, note how the resistance changes when unplugging a module with a terminating resistance and unplugging a module without a terminating resistance. While you're measuring the resistance in the CAN network, set your multimeter to record the minimum resistance and do a wiggle test on the harness. Repeat the wiggle test with the multimeter set to record the maximum resistance. The resistance should not change when wiggling. If the resistance does change, there's a problem in the harness or connectors. If the network resistance is good, wake up the ECM and check for anything above 5 volts on the CAN high and CAN low circuits, which would mean a short to positive. You should read approximately 3 volts on the CAN high wire and 2 volts on the CAN low wire. Check for a short to ground. The resistance should be above 2000 ohms. If you suspect a defective module, measure the resistance across the CAN high and CAN low terminals. If the module has a terminating resistance in it, you should measure close to 120 ohms. Modules without resistance should measure in the kilo ohms. Any modules with a resistance below 100 ohms have a problem and can prevent communication on the CAN network. In some cases, it may be easier to probe the diagnostic connector and unplug all the modules except the one to test. If there are no shorts to power or ground on the CAN network and the modules are good, measure the resistance of the wires between modules. If you measure a high resistance or get an OL reading, you'll have to repair the broken or damaged wires. CAN wires are twisted together to cancel out electromagnetic interference. The number of twists in any given length of wire is important. If you repair a wire on the CAN bus, make sure to twist the wires after the repair. 1 full twist for every 25 millimeters of wire. Now, where do you think the problem was in the Outlander XMR? Here are some pictures sent in by the technician. The ATV in question had corrosion in the air-controlled suspension module connector. This problem shorted the entire CAN network and is the reason buds could not communicate with the unit. Note, there's no terminal lock or connector seal in the picture.